Hi everyone, today we're going to talk about the rational root theorem and what it does. So let's say we have a polynomial like this one over here, and we want to find out the roots, the places where it crosses the x-axis. Typically the methods we've used so far are things like factoring, but this one's not factorable. And we can also use graphing and just seeing where it crosses, but if we're looking for an algebraic method, the rational root theorem is something that can help us out. So the theorem is listed above, starting right here. Let p of x be a polynomial, like what's in the box, with integer coefficients. Let p be a factor of the constant, so the constant's 4, the plain old number is the constant. And let q be a factor of the leading coefficient, that would be 6. The leading coefficient's the number in front of the variable with the highest exponent. So if we take those p and q values, and divide them in the manner shown here, that will give us a possible root of p of x. I say possible because we're going to have to further rule them out after that. So let's start out with finding our p and q again. So p, again, is a factor of 4. So factors of 4 are numbers that evenly divide into 4. And q is our 6. So factors of 6 will be numbers that evenly divide into 6. So I've got those here. Don't forget the plus or minus because positive 1 is a factor of 6, as is negative 1. So it's important to do the plus minus. So now the theorem says take the p over q values and create possible roots. So I always start with the p value. Let's just say 1. And I'll go through one at a time, taking this p value over this q value, this p value over this q value. So if I just start with the 1, okay, because we're looking for p over q. This is p, this is q. I'm going to do plus or minus 1 over 1, which is just 1, but I'm just going to write it there so you can see the p and the q. And then go back to the 1 again. So plus or minus 1 over the second q value, which is 2. Plus or minus 1 over 3. Plus or minus 1 over 6. And now I'll do it with the other p value of 2. So I'll do plus or minus 2 over the q value of 1. Oops. Plus or minus 2 over the q value of 2. I'll reduce them later. Plus or minus the value of 2 over 3, and plus or minus 2 over 6. And then I'll do the third p value, which is 4. So plus or minus, again, p over q. So plus or minus 4 over 1, plus or minus 4 over 2, plus or minus 4 over 3, and plus or minus 4 over 6. So now what we're going to do is take this list right here, this list of possible roots. We're going to simplify and write with no repeats. So I'll start out with 1 over 1. Now 2 over 2 is also a 1, so plus or minus 1. Then I have a half and a third and a sixth. Those I can write out because as of right now they're not repeating. And now I get here and I see a 2, so that's not been on the list so far, so I'm going to write that. 2 over 2 is on the list. It's already there as a 1, so forget that. And then 2/3 is not on our list yet, so I'll include that number. 2/6 is reduced to 1/3, and that's already on the list, so forget that one. Next up would be plus or minus 4. 4/2 is 2. We already have that. 4/3 we do not have. And 4/6 would reduce down to 2/3, and we already have that on our list. So here's my simplified list now. Now from here, what we're going to do is you're going to use our calculator to verify what the roots are. So I have typed that into my y equals. I'm going to graph it. And then I can start by eyeballing it to see if they cross over at any exact amounts. It looks like it might cross at -1, Maybe that's a crossing at 1. I can't really tell, but I'll go to the table to verify. So it's crossing definitely at -1 because I can see the 0 by the y value, but that's the only other whole number it's crossing at. So for right now, what I can say is that my roots are, just by verifying in the calculator, definitely we have -1 as a root. The other one, I'm going to have to zero in and find. So notice how it's all kind of small in there. If I want to zoom in, all I have to do is press zoom and then option 2, zoom in. And if I press enter, it'll just zoom in so I can see it better. And not that it helps me because it's not crossing an exact place, but what I can do now is use the second calc, option 2, to find the 0. So remember, if you can't see the little blinker, look over here where the X and Y's are. So I'm going to move it down to where I am. And if I want to find out what this root is right here, remember we got to create tunnel vision, as I used to call it in class, to show the calculator that we're looking at this root, not this one or that one. So I'll create a left bound, go somewhere to the right of it, create a right bound, and press enter. And there's our other root, 1/2. So +1/2, oops, not plus or minus, excuse me, +1/2. Now the third root, start over, second calc, find the 0. We're going to move that cursor just to the left of the other intersection point, press enter, just to the right, press enter, and enter again. And that's 1.3 repeating is 1 1/3. That corresponds to this root right over here. So +4/3. So we have 3 roots that we were able to narrow down from our list of possible roots. Now, in our question, I also said, so let's write this in factored form now. So again, where did the -1 come from? It comes from x plus 1. Where did +1/2 come from? X minus 1/2. And where did 4/3 come from? X minus 4/3. And then just to make these two look nicer, what you could do is multiply the middle one by 2. So I'm going to keep this x plus 1. If I multiply this by 2, I would get 2x minus 2 times -1/2 would just be -1. And then lastly, if I multiply the third parenthesis by 3, it would get rid of this denominator just to make it look nicer. 3x minus the 3's would cancel, so I get 4. So this is what it would look like in factored form, even though we didn't factor it because, again, none of the methods of factoring worked. So that's how we can use the rational root theorem. It's a little long, but it's pretty easy. It's just a matter of taking P's over Q's and then just looking at your graphing calculator. So the homework questions I'd like you to work on for this section are these right over here. Answers are in the back of the book. And we'll tune in next time to learn something else. Have a good night.